Hello, my name is Danielle Bragg, and I'm a senior researcher at Microsoft Research. I'll be presenting work on exploring collection of sign language videos through crowdsourcing, joint work with Abraham Glasser, Fyodor Minakov, Naomi Caselli, and William Thies. Most of today's communication and information technologies are designed around spoken and written language. This includes written publications, search engines, email clients, and social media. As a result, they generally do not well serve users who prefer a signed language. Developing machine learning modeling of sign languages could help enable new user experiences, for example, to look up a sign by demonstrating it, but progress in sign language modeling is largely blocked by a lack of appropriate data. Current sign language datasets are orders of magnitude smaller than spoken and written corpuses. In addition, they suffer from a lack of fluent deaf signers, lack of signer variety, lack of recordings in real-world settings, and a lack of complete and appropriate labels. To enable signing communities to curate sign language datasets that overcome these limitations, we consider the possibility of crowdsourcing sign language videos. Crowdsourcing has been used successfully in other domains and has the potential to increase diversity, for example, by reducing geographic constraints, travel barriers, and time constraints, and by enabling recording in real-world settings. Crowdsourcing also has the potential to increase scalability by not requiring specialized hardware, leveraging reusable infrastructure, and enabling parallel contributions from the crowd. Crowdsourcing sign language videos also presents challenges, though. Existing infrastructure generally does not support video crowdsourcing tasks. In addition, how to design effective tasks for video creation, labeling, and cleaning is unexplored. To explore crowdsourcing sign language data, we ran a user study with two main crowdsourcing task probes, which required building our own crowdsourcing platform. We had 29 participants, 10 deaf or hard of hearing, and 19 hearing. The first task was to record a video of a sign. First, a model sign plays with English gloss optionally shown. By default, the gloss is not shown to encourage participants to focus on the ASL rather than the English word, which may map to a number of different signs. Then, the participant records their own version of the sign. After recording, the video is playable and re-recording is enabled. This task design removes the need for post hoc labeling, since the prompt can be used to label user videos. We asked each participant to record each of 60 diverse signs. In total, we collected 1906 videos, 1696 replications, 29 additions to another part of the website, and 180 bonus contributions. Following a method established in prior work, we paid 2 ASL experts to review each video to determine if each video contained the sign from the prompt. In total, 96.67% of our videos did. This result is similar to prior work, which collected videos through a controlled mobile task with 98.75% matches. The second crowdsourcing task we explored was for quality control. Here, the user views the model sign at left and a user sign at right and is asked whether the two signs match. This task was designed to reduce the need for data review and cleaning after collection, which can be a significant barrier. We asked each participant to check 60 videos. 30 had injected errors and 30 were of other participant videos. In total, we collected 2,331 quality control checks, 840 requested control video checks, and 840 requested video checks. In addition, participants contributed 651 additional checks beyond what we asked for. Some people seem to really like this task. Here we have participants' accuracy for each type of control video. Correctly signed videos at the left, and 5 types of injected errors at the right. Non-signing content, signing incorrectly, multiple words when a single is expected, visually similar signing, and a different sign with the same meaning. For all video types, each type was correctly checked by most participants, over 50%. Visually similar signs were the most difficult error type to catch. And aside from this error type, the crowd's ability to correctly evaluate each video type was strongly statistically significant. We also asked participants for feedback on benefits and concerns with using the platform overall. This slide shows the results with percentages for DHH, or deaf and hard of hearing participants, and hearing participants separated, with the most popular answers for each group highlighted. The top benefits were contributing to better ASL technologies, which was the most common benefit to DHH participants, understanding how other people sign things, engaging in a community of ASL signers, contributing to science and research, and practicing my ASL, which was the most common benefit to hearing participants. The top concerns were who owns the set of videos, which was the top concern for DHH participants, who has access to the set of videos, what technologies will be built with this data, and privacy, which was the top concern for hearing participants. Please check out our paper for more information on other platform interface features, like a dataset view and social features, for more information on quantitative results and other qualitative feedback. Future work includes exploring real-world scalability, iterating on crowdsourcing task design based on results from our user study, developing workflows to collect continuous sign language data as opposed to individual signs, and researching methods to potentially alleviate concerns such as data ownership and privacy. Thank you.